Okay, welcome back. Now we're going to do another example. And so here is inverse sine. So we're going to take the derivative of inverse sine, or what we call arc sine. So some textbooks call this arc sine. Depending on the textbook, you could have, they'll use the inverse symbol for inverse sine, inverse cosine, inverse tangent, and so on. Or you'll hear them put, say, arc sine. So they'll write arc sine. Arc sine is the same as inverse sine. And arc tangent is the same as, inverse tangent, right? Or tangent inverse. Okay? So just so you know, you may or may not have already known that. Okay, so now, what we're going to do is we're going to consider the interval from negative pi over 2 to pi over 2. Okay? And so over that interval, we know that the inverse, right? So f of x, the inverse of sine inverse is sine, right? So that should make sense. So now, let's consider, okay, so we'll call this case 1. So let's consider from 0 to pi. Or pi over 2, I should say. Okay, so f inverse of x is cosine x, right? So f inverse of g of x equals cosine of sine inverse of x. So now, let's figure out how we're going to do this. Now, some of you might already know this, but if you don't, again, let's dust off the cobwebs and let's come back to the unit circle, right? And so we have, let's say we have this acute angle. Right? And so on the unit circle, we know the hypotenuse, the radius of the circle is 1, which creates the hypotenuse of the right triangle. And let's say that the opposite angle, the opposite of the angle, and we'll call this theta, is x, right? Well, to get this side here, all we have to do is use the Pythagorean Theorem, and we would get this side here has to be, because it's this side squared plus this side squared equals 1 squared. So if we solve for this unknown side, we get the square root of 1 minus x squared, right? Because if we make this c, then we know c squared plus x squared must equal 1 squared, or 1. And so then c equals 1 minus x squared. We have to take the square root of that. Okay? And so, now, this is going to be the square root of 1 minus x squared. And so now, if we say, hey, let's sine inverse of x equal theta, then cosine theta is what? Well, if theta is between 0 and pi over 2, right? Or x is 0, yeah, I'm sorry, x is, theta. That's I don't want x there, this is theta. Okay? So let's sine inverse of x be equal to theta. Well, then, excuse me, from here, what do we get? Cosine of theta is square root of 1, the square root of 1 minus x squared over 1, which is just the square root of 1 minus x squared. Okay, now, so now, what do? Well, now that we know this, well, now we can find g prime of x. Because remember, g prime of x is 1 over f prime of g of x, right? The one notation. So now it's just going to be 1 over the square root of 1 minus x squared. And if you look at the derivative table, you will find that that is one of the derivatives. Or is the derivative for the inverse trig functions. For, in this case, sine, inverse sine. Now, what about the case where negative pi, right? So negative pi over 2 to 0. So let's call this case 2. Okay. Well, you could do this one of a couple of ways. One, you could recognize that cosine is an even function. It's symmetric with respect to the y-axis, right? Okay. And if it's symmetric with respect to the y-axis, no, we don't want to use that. Let me think. Yeah, actually, yes. Yes. Yeah. So it's symmetric with respect to the y-axis, then this is going to give us the same result. So intuitively, whether it's negative pi over 2 to 0 or 0 to pi over 2, we see, or can intuit, that it's going to give us the same answer. But we could also use the fact that for the negative angles, we know that cosine, or you should know, cosine of negative theta is equal to the cosine of theta. Why? Well, think about it. Again, if we go to the unit circle, right? If we are in the first quadrant or in the fourth quadrant, cosine is going to be the same because look what angle, what side it shares. If you flip this triangle down, it's still, the cosine is still the same. Okay? Because the hypotenuse, right? So the hypotenuse is still the same. That's still going to be 1. Cosine, it shares the same adjacent angle, so that's going to be the same. So you can tell by using this, the fact that cosine of negative theta is always equal to cosine theta. So even if we have this, right, then what do? If we multiply all three sides by -1, we get pi over 2 is greater than negative pi, which is greater than 0. Which is what? If we do this in this order, what do we get? We get that. So we can find that negative theta is between 0 and pi over 2, which is what we just dealt with before. So, how do I want to write this? Yeah. So if I start with So yeah, let's go back to cosine. So let's go back to our thing. Cosine of sine inverse of x, right, is equal to cosine theta, which is equal to cosine negative theta, right? Which, by the same reasoning that we did over here, is equal to 1 minus x squared. So, okay, so that's case 2. Okay, now what about the case that theta is equal to 0? Called case 3. Well, if theta is equal to 0, then that means x is equal to 0, which means what do we get? Right? So we get cosine of 0, right? Cosine of theta is going to equal to what? The square root of 1 minus x squared, which is going to equal the square root of 1, which is equal to 1, which is the same as cosine 0. Oops. So it's good. So it works for 0, theta equal to 0. So it works for all values of theta from negative pi over 2 to pi over 2. And so, in all cases, the derivative of g of x, well, let's back up. So in all cases, we know that the derivative, so in all cases we know that g prime of, no. That's not the one. F prime of g of x is equal to 1 minus x squared. So consequently we get the g prime of x is 1 over this. All right. Have a great day.